frequency of an RF channel is best understood as the frequency of a carrier wave. Now, what is a carrier wave? It's a pure wave of constant frequency, a bit like a sine wave. By itself, it doesn't carry much information of a kind that we can relate to, such as speech or data. To include speech information or data information, we need to impose another wave on top of the carrier, an input signal. This process of imposing an input signal onto a carrier wave is called modulation. In other words, modulation can be thought of as changing the shape of the carrier wave to somehow encode the information that we are interested in carrying, speech or data information. It's like hiding a code inside the carrier wave. Recall that any wave has three basic properties: amplitude, which is the height of the wave; frequency, which is the number of waves passing through in a given second; and phase, which is where the phase is at any given moment. We can tweak the height of the carrier. If we create an input signal whose height varies with the loudness of our voice, and we add this to the carrier, then the carrier's amplitude will change corresponding to the input signal that's being fed into it. This is called amplitude modulation, or AM. Suppose that we change the frequency of an input signal. If we add this input signal to the pure carrier wave, we thereby change the frequency of the carrier wave. In that way, we can use changes in frequency to carry our speech information. This is called frequency modulation, or FM. We could even combine these two strategies to create a third scheme of some kind. Any strategy which combines in some systematic fashion an input signal with a carrier wave to encode speech or other useful information is called a modulation scheme. Modulation schemes can be analog or digital. An analog modulation scheme has an input wave that varies continuously, like a sine wave. A digital modulation scheme is a little more complicated. Voice is sampled at some rate and then compressed and turned into a bit stream, a stream of zeros and ones. And this in turn is created into a particular type of wave, which is then superimposed on the carrier. Why have carriers and modulation at all? Why don't we use that input signal directly? It, after all, is carrying all the information that we're interested in, not the carrier. And it only occupies a few kilohertz in bandwidth, so why don't we use it directly? Why are carriers and modulation needed at all? Well, the answer's got a few different factors to it. First of all, that kind of information could be carried by very, very low frequency electromagnetic waves. And there's a problem with this. In order to transmit those very low frequencies, you're going to need quite a bit of amplification in order to boost the power up, because they themselves don't have much power. And you're going to need some fairly large antenna in order to transmit all of this. So in order to make it cheap and convenient and use as low power to carry as much information as possible, we use this carrier system with modulated carriers. That in a nutshell is the answer.